Hello, everyone, and welcome to the first lab video recording. And in this first lab, our objective is to teach you how to implement a simple AI model for IoT data. And you can find this lab description on Blackboard and also all those resources that you're gonna need in implementing the model. Okay, so the overall plan is following these four steps. So we're gonna first set up a Python environment and um, also create data that um, is related to the IoT sensing, and then we're gonna do some data processing to data, and then build an AI model to play with data, and then finally we're gonna deploy our model to see how it works in the real world environment. Of course, here real world means that we simulate the real world environment. Okay, so let's go back to the Visual Studio screen. So as you know that in our lab and for the whole course, we're gonna use the Visual Studio to implement all those models during learning. And before we start, I'd like to introduce to you a thing called the Jupyter Notebook. So we all know that if we create a new file here, we can choose the form of the file. For example, if we choose Python file, then it will show you only the a blank space where you can put all your code, and then you open the terminal to execute the code in once, or you can do this. This will execute all those codes, but there is a case where we want to execute only a part of the code. For example, let's open the resources that downloaded from the lab one material. For example, here in humidity py, we're gonna open it. And you can see here we have several parts. For example, first step, we have created data set and then data pre-processing. And also in front, we have import code packages at the front of the code. And sometimes we will only want to execute this part first and then deal with the second step. But if we use the normal Python files, we're gonna execute them all in one, so you don't have chance to modify the part of the code and then execute only part of them. So we're gonna use the Jupyter Notebook to help us achieve this goal. So we're gonna here still open the new file, but now we're gonna choose the Jupyter Notebook. And you can select your Python version here by clicking this IPyKernel, and then it will give you several selections. Assume you have several different Python version in your computer, you can select one of them here. Also, it's important to note that Jupyter Notebook is just for um, simplifying or make you working more convenient. It's not a must, so you can still work with the original Python file only. But here we're going to introduce this to you just for demonstration, and I'm going to use it in the following lab video. So here we have a general face of the Jupyter Notebook, and you can add a code. Here you can see a block. So if you click the execute cell, it will only execute the content of the block. So you don't worry about that. It will affect other part of the code. And we can also add markdown that can illustrate what this block is about. For example, for the first block, it was import packages, so I add a markdown here to demonstrate that it was for the import packages only. And here following we have a code block. So if I execute the code block here, if it shows you a ticket here, it means success, and it means that there is no bug in this block, and all those packages has been imported to the Python environment successfully. And you can see here we gonna use the first one NumPy that will deal with the uh, data infrastructure in the basic level, and also the pandas where we can use it to create a data frame. Uh, as here is at this lab is only for the introduction to IoT, AIoT, so we will not go into all those Python packages deeply. You can always check how the packages are about and what are inside those packages by using the Google to search for the Python packages. So we will not go deeper here so much. We're just gonna introduce to you that the first one is about the data, and the second one is about creating a data frame, and then the third one is about plotting the figure that can show you basic frequency or basic pattern of the data. And then here, Scalon is a package for the neural network models that we're gonna use in the AI model part. We'll go into the basic introduction of the AI model in that part, so don't worry about that at this moment. Mm, and also here, standard scalar is used to standardize the data. As you can see that most of the time that we collect data from the real world, the data is usually very fuzzy and there's a lot of noises inside the data. So we want to standardize the data so that it can enable the model to perform better. And a third one we introduced from the package called scalar matrix is used to help you measure how good the performance is. So it will give you a classification report and give you several metrics that can demonstrate to you how good the performance is. Okay, and finally to the TensorFlow part. TensorFlow here is a package that we use to create the AI models such as neural network, graph neural networks, and all those MLP and all those sort of uh, deep learning models. Apart from TensorFlow, you can also choose PyTorch, which is now another compiler for the AI models. And so far for the packages, we will now go to the data set creating step so that we have import all those packages. So first of all, we're gonna create a data set. Of course, you can use your own data set, but here for the demonstration purpose, we're gonna create our own because we don't have the data set available in the real world. Okay, so the data set we create is consisted of three parts. The first one is temperature, and second one is humidity, and third one is motion. As you can guess that the first two is about the sensor value that is recording in the real world. Say we deploy the sensor near our school, so it can record the temperature and humidity of, for example, the P buildings or the Q buildings. And then the motion is recording the motion of the sensor. So, for example, if we move the sensor from our PolyU to the mainland China or the United States, of course, temperature and humidity will change a lot. So here we want to use temperature and humidity to predict whether the sensor has been moved or not. Because we don't have the real data, so we're gonna hear fake data. As you can see that there are 1,000 data point, and the first one, random seed, is used to control the random generation of Python. And for the temperature, we're gonna choose to randomly generalize the temperature that has a normal distribution around 25 centigrade degree, and that is usually in summer, I guess. And also the humidity is around 50%. For the normal distribution, humidity is around 50%. And for the motion, whether the sensor has been moved or not, we choose to create a certain percentage chance. So for the not moved motion, meaning that the sensor is standing in the way that it's already originally is, it was zero value. And for the sensor that has been moved, it was one value. And we have 70% chance of not moving the sensor and 30% of the chance for moving the sensor. Okay, so that we have creating 1,000 uh, times of temperature and 1,000 times of humidity and also 1,000 times of motion value. And we're gonna put them all into a big data frame that allows us to access into those temperature, humidity, motion in a very in a very united way using the panels. And you can see that we can now show the hat, the first 5 rows of the data frame using the data hat code using the data hat instruction, and you can see that the first 5 rows of our data set. Temperature here, humidity here, and motion is here. Okay, so that the first step of data creating has been finished, and we come to our second part, data pre-processing. So for the data pre-processing, we gonna here first of all, we gonna check for missing values. That is very important, and you have to remember that every time you start to implement your code, you have your data ready, and then you should definitely check whether there are some missing values in the data that has been marked as NA, meaning not available, and every time NA is appear, it will certainly affect your model performance because NA has been imported to the model and the model has no idea how to deal with NA definitely because there is no values. Okay, so we're gonna check whether there are missing values. But here we have all those data that has been created by us by hand. So of course there is no values, and you can see here there's no missing value in each column. But there are sometimes that could be missing values. You can either replace them with the value you want, for example, the average value of the data or the mean value of the data. And also you can just delete them and avoid them being absorbed by the model. Okay, so after we check the missing value, we're gonna show the data set and how it looks like, whether it was really created in a standard distribution pattern. And here we have the temperature distribution figure, and in the right hand we have the humidity distribution. You can see that they are um, generally the way of the standard Gaussian distribution style. And then we're gonna do a feature selection. Remember in the first part, when we describing the basic information of the data, we mentioned that our main goal is to using temperature and humidity to detect the motion, or in another way, is that the motion is related to the temperature and humidity in a certain level. So here we choose the data temperature and humidity in the data frame as features and motion as our target. And our goal is to use the data temperature and humidity to predict the motion. But in order to do so, we're gonna split them first into training and testing dataset. Here, training and testing dataset, it's maybe a unique idea in the AI models, because AI model is not start from nowhere. It was training on the training dataset first, and then testing a testing dataset. You can think of it like it was performing certain level of training like athlete, and then the testing set is when they are joining the Olympic to really compete for the golden medal. Okay, so the general way of splitting the testing data set is that you give 20% of the data to the test data set, and then the rest of them are belong to the training data set. And here, training test split is the embedded Python method that you can call so that it will split the feature target with the test size, meaning the 20% and training set meaning 80% automatically. Okay, so we have the X training and X test, and also Y training and Y test, and then we're gonna do the standardization. As we mentioned in the first step, we use it to make the data more clean and more standardized so that it can be better performed in the model. You can just using the scalar transform to deal with this kind of standardization. Okay, so after we have pre-processing the um, data set, we're gonna then go to the third step, build an AI model. Okay, so before we discuss about the code, I'd like to first introduce to you the basic idea of neural network model, but we will not go deeply into the neural networks so much because we're gonna get into it in the following lab. But for the first lab, we just gave you a taste about the neural network model, so we will not go into deep about the mathematical um, algorithm or sort of thing, so it can bother you in a certain level. So we will not go that deeper. We'll just give you a very gentle introduction to the neural network model. Okay, uh, actually you can find a lot of instruction or a lot of online courses about the neural network. For example, here I just find a very simple blog that was created by Victor Zhou in Google, and it was going it was designed for the beginners of machine learning. So it was called Introduction to Neural Networks. If you are interested in this blog, also you can type in this title to the Google, and then you can find the blog certainly. And as we mentioned that the original idea of the AI model is that we want to predict something, maybe predict the motion of the sensor from the humidity and temperature. So for example, here for the input, we have the temperature here, humidity here, and we want to detect whether it has moved or not. So the very simple idea of them is that you can add the temperature and humidity, of course with weights, and you multiply each of them with a weight, and then you insert the final value to the model to let it know whether it's beyond a certain threshold or it's below a certain threshold to decide whether it has been moved or not. For example, if we are now in Hong Kong and we maybe have a normal temperature of 25 degrees, and then we go to maybe to the India, and then the temperature may rise to 43 Celsius degrees. I don't know, just a very simple assumption. And in that way, the input of the temperature has been rise a lot. So of course, the combination of the temperature and humidity will also arise in a certain way, and then the overall result may be beyond the threshold, and then the model will tell you that the sensor has been moved from Hong Kong to India because the final value is above a certain threshold. Okay, so that's the basic idea of the neural network. It's just like human brain. So you are given certain input, and then your neural sensor in your brain made a certain decision whether this input has been reflected to a certain output. So it was called neural networks. And the idea is very simple, but the difficult part is how to decide the weight and also how to decide the combination of the input value. So that we what the neural networks gonna do. Okay, so guessing that we are now uh, assign the weights of the temperature and humidity maybe randomly. For one, this is 0.1, and for another one, it was 0.9, and then it was multiplied by each value and then go to the model. And we can, of course, we can compare it with the real value. And loss or the differences between the real value and the predicted value, it may be very big, but it's maybe also very small. For the situation that was very big, we will certainly know that the weights we design may be different from the really from the true weights, and we're gonna maybe address the weights of the input value, maybe increase the weights of the temperature from 0.1 to 0.5, and then decrease the humidity weights from 0.9 to 0.5. In that way that we adjust the weights and we allow our predictive value to be more closer to the real value. And of course, we cannot do this kind of process by our own hand because it's very time consuming and also very computationally expensive. So what we're gonna do is that we will give the predicted value and also the real value, and then we will do the loss of the predicted value and the real value. As I just demonstrated, you can use different laws like the binary cross entropy to calculate the loss. And once we have the loss, we will calculate the derivative of the loss to the value. So in that way, we can see that the pattern of the value is related to the predicted value. Input value is related to the predicted value, and we won't change the weights to the direction that is making the loss smaller. Okay, so that's the basic idea of how neural networks gonna adjust the weights when it was given with the training data set. And it will definitely go for several epics. As you can see here, we will choose epic for 20 epics, and many times we will choose the epics for 100 times or more. And in each epic, the model will calculate the loss and then do the derivative and then adjust the weight according to the derivative. And as much as the epic was provided, the model will make the loss smaller and then predict value more closer to the real value. And in a certain epic, when it comes to a certain epic, it will converge, and then we will have our optimal model that was used for the free world deployment. Okay, so you may ask that is there a way that we can make this kind of convergence quickly or more easy to get? The answer is yes, and that's why we use optimizer. So as I just mentioned that we cannot calculate the derivative by hand, but we can use, of course, the Python to help us to do the derivative and then adjust the weight. But that is still quite a bit slow. And then we're going to use the so-called optimizer. So this was an algorithm that will still do the derivative, but different from the standard gradient descent method. And we will not go to the Adam algorithm so deeply because it's quite complicated, and if we extend it 8 so much. The length of the video may go to 2 hours or beyond. And but you can always check the Adam algorithm on Google by searching for the Adam optimization algorithm. There are videos or online courses about it. It's very clear and well designed. You can always check them. And I just showing you blog that are searched from the Google, and you can type the title of the uh, paper, and it will showing you the web page where you can read it, and then you may have a more deeper understanding of the optimizer. But for this part, you just need to know that optimizer is help us to adjust the weight of the neural network. That is enough for you to use it. Okay, and here we have epochs, and we have the input value that we just created. And also one part here, validation split is apart from the training data set and testing data set, we also have a validation data set that inside the training data set. Because each time when we train the model, we want to test it and then decide whether we want to go to that next epoch or just stop here. So we will have a validation split for 10% only for each epoch. And then for batch size, um, it was designed for those computers whose GPU size is not, whose GPU power is not so ideal. And in that case, we may decrease batch size to 10 or 8. But for those who have better GPU, we can of course increase the batch size to 32. So as you may guess that the batch size is actually the number of the data point that you feed into the model each time, so that it was highly related to the GPU power. When if your GPU power is not so good, you may want to decrease the batch size, meaning that you want to provide smaller amount of data to the model each time, so that it will not make your GPU out of power. Okay, so when we have finished designing the model, as you can see that we have a model that was designed here. It was quite different from the original um, neural network that I demonstrated to you, because here we have only one um, node that will accept the input value and then output value. But in real time, actually, we want to make these nodes uh, with more amount, because in that way it will give you more different type of combination that allow you to output the value in a more possible way, so that it can make the model perform better. So now we have not only the input layer and output layer, but we also have a hidden layer that was composed of not only one nodes, but maybe two nodes or more nodes. And we can add many amount of hidden layers here. But according to the experiences of the existing research, we will set it to um, 32. And also for the input layer, we will adjust it to 64. And for the activation function here value, as you can see here, we are only considering the linear combination of the inputs. And there are maybe sometimes when you want to also consider the non-linear combination of the input value. But according to our basic algorithm of neural networks, which is combining the inputs by using their adding value of the input value and multiple with the weights, it will never reach the non-linear value. Un um, Unless that you have add a activation function to the output of the input layer. There are many different kind of functions that can be used for um, activation function, but here we will use ReLU and sigmoid. And for the ReLU and sigmoid function, how it looks like and why it can be used for activation function. Also, you can go online for Googling, and we will not go deeper into it as we want to make make the video um, a more like a gentle introduction to the AI model. So you don't have to have a lot of maybe expertise knowledge when you are creating an AI model. You just need to know uh, what we need, what we input to the model, what we want the model to output, and then that is enough for this time. But we may go to deeper for next time or in the coming labs. And after we decide the structure of the model, we'll do the model compile. We will decide what will be the loss and what kind of optimizer that we're gonna use in the training process. And then we'll decide the apex and also the batch size. And then here, as you may see that the model is predicting the value, but because we are using the activation function, so that the output may not be integer. It may be maybe 0.1 or 0.2 or something like that. And in that way, if you want to map it to the original motion data value that we created in the first step, as you can see, it only have two kind of values, 0 and 1. You need to do standardization as well, but now we will only use the 0.45 at the threshold so that it can make the output only like two values, 1 and 0, because it's only returning you two kind of Boolean values, 1 or 0, and then we change the Boolean value to the integer type. Okay, so that accuracy here is whether is the differences between your predicted value and the um, real value, and it will help you to measure how good your model performance is, and you can see that the accuracy has been printed each time, and then it will give you a printed classification for here. It will give you the basic information of the model, like the accuracy, how good it is. You can see here we have 69% of successful predicted value. That means that 60% of our value is same to the predicted value. And we also have weighted average and macro average that was used for the measure of the performance of the model. Okay, so now we have already training our model, and it has been reached a certain level of convergency, and we want to test it on our real world data set whether it can really be used to test the motion of the sensor. So we will create a new data point that was still example of training or example of testing. It had temperature of 22 Celsius degrees and also humidity of 55%. And we will give the new data as the input of the model. Of course, you're gonna standardize it first, and then the model will do the prediction. And then if the value is bigger than 0.5, then it will give you yes, meaning that the sensor has been moved. And then when the predicted value is less than 0.5, meaning the motion is 0, and meaning the model is not, meaning the sensor has not been moved, and it will give you no. No. Okay, so that's the fourth step or of our first lab. And in this first lab, we just gave you a taste of how a data set looks like and how we can pre-processing data set to get to our AI model, and how our AI model like neural networks can help us to predict the values. And that's all. And if you have any questions related to the neural networks or the data set, you can send email to our TA teams, or you can search online, or you can ask the ChatGPT for help. And thanks for your listening, and see you in the next lab. Thank you.